Hello everyone, and today's lesson is on systems of nonlinear equations. So we'll talk about linear and quadratic equations, where you have a straight line and a quadratic graph, which could be like a circle, ellipse. Ellipse is kind of like an egg or an oval, okay, um, or a purple or something like that. Okay, and then we'll talk about when you have two quadratics. So the major difference is one has up to two solutions. The other one can have up to four. Okay. Now, the first type is what we call linear quadratic systems. So this is the first type, and in this type right here, you can have 0, 1, or 2 solutions. Okay. Now, an example of this would be like dealing with profit functions, or like meeting with demand and supply curves. So that's an example. And if you ever take business math, or if you're a business major, you will see this in college. Okay, so here we go. All right, so like the first one here, this would probably be the most common problem right here. So if you notice, um, they cross here and there. And what I want to do is zoom in real good here, because we have to pick the solutions. Okay, there. Wait a minute. There we go. All right. So we have to pick this point and that point, right? So that means they cross each other two times. So we're going to have two solutions. But how do we know what the solutions are? Again, it's where they cross it, right? So all we need to do is, what is that point right here, right? Well, I just need the x and y coordinates. So to do that, I have 2 points. Okay. All right. Okay. So this one right here is going to be 0, comma, -3. Okay. That'll be the first one. Okay. 0, comma, -3. Okay. Now the next point is right here, right? So to get the x value, just count over to get underneath the point, which is 4, and then go up, and then right there I went up 5, right? So the two solutions would be 0, comma, -3 and 4, comma, 5. Okay. So in this particular problem, there are two solutions. Okay. All right. And again, I got 0, -3 because the x value, I didn't go left or right, and then I have to go down 3 to get the y. Okay. All right. Now for the next problem, okay, how many solutions do we have? All right. Well, look right here. This is the only point where they cross. Okay. So we only have one. What are the solutions? Well, all right. So we start here at the origin. So it means we go left 2 because we're underneath the point. Go up, and it crosses at -2, comma, 5. Okay. So again, over 2, up 5. So the answer to this one's going to be -2, comma, 5. Okay. All right. Now, the last one here. Okay. You know how many solutions do you have? Well, do they cross each other? Nope. So no solutions, 0 solutions, no solution. That's it. Okay. All right. So that's all we do on that. Okay. So the next two, I am going to work here on Desmos. Okay. So what we're going to do is go down here. We're going to go down to 4a. and we're going to work 4b. Okay. All right. So this one is x plus 2 squared, quantity squared, subtract 6, y equals 4x minus 2. So what I'm going to do, I'm going to type that in to Desmos. Okay. So I'm going to be going in and out of Desmos quite a bit here. All right. We're going to go there. All right. Okay. All right. So the first one is y equals x plus 2. Now remember to hit the exponent. The square one's right here. So just make sure you're on the outside of the parentheses. Okay. Minus 6. Okay. All right. I don't need this anymore. Y equals 4x minus 2. Okay. All right. So this one's kind of, look how close it is. See, if we were to graph with this on paper, we wouldn't even notice. Okay. So we're going to go in. We're going to zoom in here, right? Okay. If you notice, let's follow the graph here. This one's kind of difficult. If you look here, it only crosses once, doesn't it? Okay. All right. So it's going to cross about right there at 0, -2. Okay. Now, to make sure this is correct, you can do this. Okay. We can type in what we see. Now, you only want to do this if they're close to each other. So normally you don't have to. Okay. All right. There should be a solve in there. Maybe not. Nope, it isn't. Okay. This used to have a solving utility in there. Oh, okay. All right, I won't worry about it then. So our solution here is going to be 0, -2, okay, because that's where they cross each other. So when we write our answer, okay, all right, when we write our answer, we're going to write 0, -2, okay? All right, you can check that just by plugging in 0 for x, and that'll tell you if you're correct or not, okay? All right. For the next one, okay, this one won't be as bad. So we'll go ahead and type that in. Okay. I wish there was an easier way to do this. All right, so for this one, we got x squared minus 2x minus 3. Okay. And then the next one is y equals -5. So I got to scroll out here. There we go. Okay. Now, all right, now this is the red line, right? The red curve. See how that's curving here? Okay. That curves because it has a square on it, all right? Looks like a comet, right? So, but then down here, that's our blue line because see right here, that's our blue line right there, right? So notice, they don't cross each other. So in this problem, what we're going to do, they don't cross. So what we're going to do is write no solution. Okay. I'm going to do the last one because I think that one's going to be 2 answers. Okay? All right. Okay, so this is the last one for this part. All right, we're going to go back in Desmos. Okay. All right, so now I'm going to get rid of that. Okay. And plus 7. Okay. Now remember, it can only intersect at most 2 times. Okay. All right. So let's get. All right. Now, what do we notice? It's twice, right? Okay. Now, how do you know which points? Now, some people have trouble, even with glasses, even looking at the graph, especially when you get old, it's even harder. Um, I mean, I'm blessed with good eyesight, but some of my friends aren't. So this is how you take care of the problem. See where they cross? See right there? Just click on it and put a point down, right? So our first answer is going to be -1 comma 4. Our second answer, see it has a point down there, right? Already. So the second one is going to be 5 comma -8. Okay. So that's going to be our answer. And once we do that, we come up with the two answers where they cross each other: -1 comma 4, 5 comma -8. Okay. Um, okay. So this is what's going to happen. This is here what you call a solution set. So we talked a little bit about this earlier in the semester, but not much. So your solution set would be -1 comma 4, 5 comma -8. So normally you would see your answer like that. Okay? Yeah, that's it. That's all you have to do for this. Okay, nothing else. So that's what happens when you have a linear and a quadratic system. Now, when you have two quadratics, okay, then things change. Okay. All right. So let's take care of that. All right. I should have used that as the assignment. It'd been easier. All right. Now the only one we're going to use from this is this particular one right here. Okay. So when you have two quadratic systems, it could be, you could have up to 4 answers. Okay. So like this one, notice that they never touch each other, right? Okay. Another example of where quadratics don't touch each other might be something like this. So an example what might be, you might have a circle here and a parabola there. Okay. So you might have a hill and the moon, right? Okay. So if you think about it, the moon's, it's not going to hit the hill, right? So you're standing up here. Yay! There we go. Okay. All right. Woohoo! All right. There we go. All right. Notice they don't touch, right? So that's an example of no solution. Okay. All right. You have one. You have two solutions. This one is 3. There, there, and at the very bottom. Okay. All right. And then here. Okay. All right. Now, I'll give you a real good example of real life. Well, I won't say it's real life, but it deals with space, right? Well, if you have, like if you have two planets, all right? Let's say Neptune. Well, Pluto is no longer a planet. They deplanetized that a long time ago, and one orbit is like this, and the other one's kind of like this, and it just pops in every like it's for 20 years. I think it's like for 20 years, and so I know that's horrible looking. That needs to go inside. There we go. Now we can see it. So right here and here, okay, are where the orbits cross each other, right? Okay. So this is for Neptune. This is Pluto. Okay. Now remember, Pluto is considered a dwarf planet, and actually, they're considering a dual dwarf planet system because one of its moons is tidally locked to it. So it's kind of cool stuff. But yeah, notice how they actually cross each other, but they never collide into each other. But that's something important to know because astronomers have to know this stuff as well. So even in outer space, now there are a lot of things in real life that you do use, but a lot of it's business oriented. Okay, all right, and also during the first Gulf War, um, Iraq was firing our own missiles. They're called Scud missiles, and they're firing them at Israel. And Israel had we sold them the Patriot missiles. Now, luckily, Scud missiles don't hit very well, so I don't think it actually damaged too many places real bad. But at that time, that was pretty bad. And what does that have to do with the lesson? Well, you're talking about two parabolas, two quadratic functions. Where do they meet at? So at some point, the Patriot missile is going to intercept the Scud missile to make sure nothing happens. And not only that, but they have to actually measure, um, like they just can't have the missile intersected over a populated area. Now, if you know anything about the Middle East, it's fairly populated. A lot of the countries are real small. Um, Now, of course, once you get to Iraq, there's a lot of desert there. But kind of like around Jordan in those countries, Palestine's not a country; it's a territory. But it's a real small place. I mean, so it's very populated. So when they were firing missiles during the first Gulf War, they had to make sure that this is the math that they used to make sure that the Patriot missiles intercepted the Scud missiles in a way that didn't land over populated areas. So, um, that's kind of scary stuff. Um, so, and I hope nobody ever has to go through that in their lifetime here. But um, I want to point that out because that is a real life application. Okay. All right. Um, Now, right here, how do we handle systems quadratics? Now, what we're going to do, we'll do this. I like this problem right here because I think it's one of them on the homework I put. Notice how the signs are almost like they're only off by a sign right here. So that's the reason I'm picking that one to work out. Um, and then I'm just going to make up one because I want to have some fun. All right, so here we go. Um, so actually, that first one, it's kind of hard to see. So it's x squared plus minus 2x plus 4. The other one has a negative x squared. Okay. Don't. Okay, there we go. Okay, hit the wrong button. All right, so we're going to go here. All right, we're going to decimals. All right, so cross that out, cross that out. All right, now we're going to go to y equals. And what another good thing is this is going to lead into the next unit anyways. This is what I like about it. Okay. Because you're going to see what happens when we change just like one sign on the graph. Right. I can't copy and paste. Can I? I used to do that. X squared. All right, notice they're the same, right? They're just off by a sign. Look at this. Oh man, those two graphs don't cross each other, do they? No, they don't. So notice what really makes it bad. See how this one's positive? It's in black. So notice it's open upwards and the red one is open downwards, right? There's a reason for that. We're going to be learning that in the next week or so. All right. So that one has no solution. All right. So I'm going to write down no solution for this one. Okay. Because they do not intersect. All right. Okay. So what I'm going to do here is I'm going to take one of the problems that's on one of the sheets here, and we're going to look at. All right. So what we're going to do now, what this one looks like, and the reason I picked this one is because in the notes, and this is the one that's online, they actually give you a graphing, so we can actually here just make sure that our answers are correct. So when we graph this, we can make sure it's correct. Now notice here, this function's a circle, right? So there's a y square there, so that changes everything. All right, so right here, this is the curve function right here, and we're going to come back to that in just a second. And this one right here, there's a reason it's written in that form. Now in geometry, you're taught this, so you may remember from geometry that the center would be 0, comma, positive 2, which would be right there, right? So, all right, we're worried about where they cross at. So we're going to type these in into Desmos, and we're going to make sure we match up with what they have, right? All right, so here we go. All right. I don't even have to do anything with that, do I? And also remember that second graph is not a function either, so, okay. Plus 1 minus 2 equals 4. All right, click the plus symbol to zoom in. And if you notice here, you're going to come out with the same answers. Okay? All right. There we go, right there. Now, notice it's not an exact number, right? So if you actually were to solve this, it says negative 1.732, comma 3, right? All right. Now, I'm going to show something here real quick. So we'll come back to that. Let's just hold that thought right there. Negative 1.732. Okay? All right. So, I'm going to stop playing with me. Okay, what we're going to do here. No. All right. Watch what happens when we type in the square root of 3. So we hit that. Look at that, 1.732, right? All right. How did I get square root of 3? Uh-oh. Guess what? Okay, well, look right here. That's how I got 1.732, because the square root of 3 is about 1.732. Okay. All right. So we're going to go back here now to the graph, and we're just going to get our answers off there. So I just want to draw a connection there. So that's not something that's too big. So we have a solution here, here, and there. Okay. So our answers are just going to be, and I'll put them down here on the paper as well. Now remember, the decimals there are just they're estimates or approximations, so they're not exact answers. Square root of 3 would be the exact answer. Okay. All right. So we're going to go here. Okay. So these are our 3 answers right there. Okay. And really, that's how you do that type of problem. Okay. So, all right. One last one. Okay. And this is like something that's on the assignment. All right. So this one is, I can't remember if I actually used this one or not. So if I did, you're getting an answer. Woohoo! So, all right. Does that look nasty right there? That looks pretty nasty. I mean, that problem looks kind of gross and disgusting. And but you know, we don't have to solve it using algebra. So So let's go ahead and do this. We're going to go ahead and put this into decimals. There we go. I always want to hit the wrong tab. There we go. Okay. So this is the last problem here, all right? So that one's going to be x squared plus y squared minus 20y plus 7. Okay. All right. Make sure I got everything in. I'm missing the 8x. Make sure you type in everything. So it's x squared plus y squared plus 8x minus 20y plus 7. All right, now the other equation, all right, make sure you put the 0 in there. All right, now we're good. All right, now the other one is also x squared. Okay. All right, now notice this one's a non-y squared. So that's going to kind of affect the graph a little bit. Okay. All right, so I'm going to make sure I got everything there. Yes, we do. All right. Look at our graph here. Okay. Now the overall graph, look at that. One's a circle. The other one's kind of an ellipse, right? So this one's actually pretty straightforward. See this graph right here? The red one? All we got to do is figure out where it crosses. So we're going to scroll in. All right? And it crosses here. Right there. And there. Okay? So our answers are going to be -7, 0, and -1, 0. Okay? All right. Okay, so that's our two answers. That's all we have to do. Just type them in. And what I'm going to do here, all right, it says these are our two answers, right? And then they work it out algebraically on here. And then look at the bottom down here. Boom. Those are our two answers. Look at that. So look how much math is involved in this. It's a lot. So good thing you only have to use graphing on this. All right. Okay. So that's it for this. So we're going to stop here. And all right, so stop the recording.